Hello everybody and welcome to my very first video as I am Bones Malone and I'm here to provide some chemical analysis, help, tutoring, homework advice, whatever it helps suits you. Now today we're going to be starting with a problem commonly found in gravimetric analysis. We use gravimetric analysis to analyze the concentration or weight or certain properties of a specific substance that we're trying to determine. So for example, if we have AgCl and we're trying to figure out the molarity of Cl or the grams of Cl in that unknown or the number of moles of Cl in that unknown, we would perform gravimetric analysis and then we would use our data to find what we're looking for. So a practical example of this is if you had chloride and a number of other things in a water sample. Trying to figure out how much chloride you have in said water sample, you perform gravimetric analysis to find that out. Now for this example here, we're using silver nitrate and silver chloride. Now this is also fairly common because silver nitrate and silver chloride can react together to make silver chloride. Oh, I'm sorry. Silver and silver nitrate silver nitrate and chloride can react together to form silver chloride, which is an insoluble precipitate in water, which means that AgCl is not soluble in water, so it forms a salt, which is very easy to weigh because it's really more difficult to weigh liquid for the purpose of measuring mass. So once you get AgCl as a powder, you can weigh it, and then you can find the amount of Cl that was in your original unknown sample. So today we're going to be finding the molarity of Cl in the unknown. Now we know we have 0.4368 grams of AgCl, and we have 10 milliliters of an unknown solution. So first we have to start out the problem by finding the moles of Cl. So how are we going to do that? We're going to take our grams of AgCl, so 0.4368 grams of AgCl, and then we're going to multiply it by 1 mole of AgCl over the molar mass of AgCl, which is 169.87 grams per mole. You can look this up or consult with your periodic table and add it up yourself. 87 grams. Now, the reason grams go on the bottom is because grams are right here, and eventually, by the time we're done with all the math, they're going to cancel out and leave us with moles. So next, we have to find, currently we are in moles of AgCl, but we don't want moles of AgCl, we want moles of Cl. So 1 mole of Cl minus and 1 mole of AgCl. Now remember, AgCl is on the bottom because AgCl is up here. Like moles of AgCl up here, moles of AgCl down here. Because now we can cancel moles of AgCl, moles of AgCl, grams of AgCl, which leaves us moles of Cl. So after we pop this in our calculator, we're going to get 0.00257, if I fix this 2571 moles of Cl minus. Now we don't want moles of Cl minus, we want the concentration of Cl minus. But now that we have moles and we know the formula for concentration is moles over liters, we can solve this equation. So now that we have moles of Cl, all we need left is liters. Now we know we have 10 milliliters, but we can't just add milliliters because the formula requires it in liters. So now we're going to take 10 milliliters and convert that to liters. So how do we do that? So we're going to, just like we did before, if it's on the top, move it to the bottom. So we have 10 milliliters on the top. So we're going to have 1,000 milliliters on the bottom and 1 liter up top, because there is 1,000 milliliter or Yeah, 1 liter in 1,000 milliliters. So this is going to give us 0.01 liters. So now that we have moles of Cl and liters, we can finally find our concentration of Cl in our unknown sample. So now we're going to do 0.00257 moles of Cl minus over 0.01 liters. And that's going to give us our answer, which we're going to want to now plug in our calculator, which is going to give us 0. Oh, it's a pretty bad 0. We'll go ahead and fix that. Which gives us 0. That one's not much better, but that's okay. 2.6 moles over liters. Capital M stands for concentration, but it's or moles over liters. Bam, so this is going to be our answer. So now this is going to be of C. So now what we did was we took our initial sample, which we measured to be 0.4368 grams of AgCl. We converted that to moles of Cl. Then we took the 10 milliliters we knew we had in solution, converted that to liters, and then we did moles over liters, which is the volume for concentration, to get our answer, which is 0.26 moles over liters. Now that's our concentration of Cl. Now the reason we did 1 mole over 1 mole here is because if you balance your chemical equation, which I will not do for you, you'll find out that there is going to be 1 mole of Cl or 1 mole of AgCl, and that's why we did 1 to 1. If there was 2 moles of, if this is a different problem with different molecules involved, we might have 2 moles of one portion over 1 mole of the other, but that's why you have to make sure that you pay attention to your balanced chemical equation to make sure that your molar ratio is correct. So after that, we've looked over everything. I've showed you how to perform a gravimetric analysis equation of finding the molarity of a specific substance inside an unknown solution. I hope you enjoyed the video. The quality will maybe improve in the future depending on how this channel goes. Don't forget to like, comment, and subscribe, and I'll see you another time. Bye guys, have a good day.